Hello and welcome. My name is J. Aquadaba. Today we'll be looking at probability, and we will specifically look at the independent and dependent events. Okay, so let's consider independent events. If A and B are two independent events, it means the probability of A and B occurring is equals to the probability of A multiplied by the probability of B. Let's say if we have A and B as independent events, so it means the occurrence of A does not affect the probability of B, and the occurrence of B does not affect the probability of A. Okay, so we will use two DAs to give an example of independent events. Suppose you roll a red number dice and a blue number dice. What is the probability that you will roll an odd number on the red number dice and number 4 on the blue number dice? Okay, so rolling these two dice, okay, a red number dice and a blue number dice, you come to realize that the occurrence of any of the numbers on the red number dice does not in any way affect the event on any of the numbers on the blue number dice. Okay, so since they do not affect one another, it means they are independent. They are independent events. Okay, so let us see this now. What would be the probability of A and B occurring? Okay, so for the red number dice, the probability of the odd number appearing on the red number dice is equals to the event for obtaining an odd number on the dice. We have three odd numbers, 1, 3, and 5. Those are the odd numbers on the dice. So it means the event for obtaining an odd number on the dice is 3, and we know the total outcome is 6. So it means the probability of obtaining an odd number on the red number dice is 3 divided by 6. And 3 into itself one time, and 3 into 6 two times. So you have 1 over 2. So 1 over 2 is the probability of obtaining an odd number on the red number dice. Then we are also going to find the probability of obtaining 4 on the blue number dice. Okay, so the event for that is 1, because we have only one number 4 on the dice. So the event is 1. So it means the probability of obtaining number 4 on the blue number dice is 1 divided by the total outcome is 6. Okay. So then in order to find the probability that A and B will occur is to multiply the probability of A by the probability of B. So the probability of obtaining an odd number on the red number dice and number 4 on the blue number dice is equals to the probability of obtaining an odd number on the red number dice, which is 1 divided by 2 multiplied by 1 divided by 6, which is the probability of obtaining number 4 on the blue number dice. So we multiply these two numbers. We have 1 times 1 is equals to 1 divided by 2 times 6 is 12. So 1 divided by 12 is the probability for obtaining an odd number on the red number dice, and at the same time obtain number 4 on the blue number dice. Okay, so let us see dependent events. If A and B are two dependent events, then the probability of A and B occurring is the probability of A multiplied by the probability of B after A. Okay, because for dependent events, let's say A and B, the occurrence of A will definitely affect the probability of B. All right, because when we find the probability of A, and then it means the total outcome will be reduced, which will affect now the probability of B. Okay, all right, so let us see this as an example. The refrigerator contains 15 drinks, 5 apple drinks, 8 orange drinks, and 2 mango drinks. Avinan is the first in line for the drinks, and Kevin is the second. what is the probability that Avina will receive an apple drink and Kelvin a mango drink if they are given drinks at random? Okay, so we have the refrigerator and we have 15 drinks in the refrigerator. And that 15 drinks, it contains 5 apple drinks, 8 orange drinks, and 2 mango drinks. Okay, so 2 plus 8 plus 5 is 15. That gives you the total drinks 15. And Avina and Kelvin are in line to receive drinks from these 15 drinks. Avina will be the first to receive drink and followed by Kelvin. But what will happen is for the probability for Avina receiving an apple drink, okay, is it what it says? Yes. Avina is the first in line to receive a drink, and Kelvin, what is the probability of Avina receiving an apple drink? Okay. So the probability for Avina receiving an apple drink is the total number of apple drinks divided by the total number of drinks. Okay, so we have 5 divided by 15. So what's going to happen when Avina receives her own drinks? And the total number of drinks that will remain for Kelvin to choose from is now 14. It means the probability now for Kelvin receiving drink from these 15 drinks have been affected by Avina choosing one of those drinks. So it means these events are dependent events, okay? All right, because the occurrence of one will affect the probability of the other. Okay, so let us see what we do here. So we are going to find the probability of the apple drink that is received by Avina, and we have 5 apple drinks and divided by 15. So we have 5 divided by 15, and 5 into itself is 1 time. 5 into 15 is 3 times. So we have 1/3 as the probability for Avina receiving an apple drink. And we are also going to find the probability of Kelvin receiving a mango drink. And we have 2 mango drinks, okay? So it means the probability of a mango drink after the apple drink has been chosen is actually 2, because 2 is the event. We have 2 mango drinks, so 2 becomes the event. And now the outcome, the total outcome is no longer 15 because Avina have already chosen 1 apple drink. So the total outcome now has been reduced to 14. So we have now 2 divided by 14. And 2 into itself is 1 time. 2 into 14 is 7 times. So we have 1/7 as the probability for Kelvin receiving a mango drink after Avina have taken an apple drink. Okay, so it means the probability of an apple drink being chosen and then thereafter a mango drink be chosen is the product of the 2 of them. So it's 1/3 multiplied by 1/7. So 1 times 1 is 1 and 3 times 7 is 21. So it means 1/21 is the probability that Avina will receive an apple drink and Kelvin will receive a mango drink after Avina have chosen. Okay, so let us see another example. Okay, we dealt with this in our previous lesson. We said that a deck of cards contain 4 suits, and each of the suits have 13 cards, and we have 2 black suits, so 13 plus 13 will give you 26 black cards, and we also have 2 red suits. 13 plus 13 is also 26 red cards. So 26 plus 26 give us 52. So we have a total of 52 cards in a deck. Okay, so let's see this problem. 2 players are playing a card game. What is the probability that player A select a black card and without replacement, player B select a number 2 card? Okay, so from here we clearly see that these are dependent events. Okay, for player A, when player A selects one of the cards from this deck, the total outcome will be affected for player B selection. Okay, because we have 52 cards originally and player A will select one of them. Then when player B is about to select, is no longer 52, but will become now 51. So it means the total outcome will be reduced by 1. So it means these are dependent events. So what we do is to find the probability of A selecting a black card. Okay, so let's do that. So the probability of A selecting a black card, we have a total of 26 black cards. Okay, so 26 becomes the event and 52 is the total outcome. So we have the event divided by the total outcome, 26 divided by 52. 26 into itself is 1 time, and 26 into 52 is 2 times. So we have 1 over 2. So that's the probability for player A selecting a black card. And let's also find the probability of player B selecting a number 2 card. Okay, so and that is after A has already chosen from this deck. So we now have 51 cards. So it means the total outcome is now 51 instead of 52. All right, so the even for selecting number 2 card, we have 4 suits, and each of the suits have a number 2 card, 1 number 2. So we have 4 number 2 cards. So 4 is the event. So we have now 4 divided by 51. That's the probability for B after A. Okay, so for the probability of A and B occurring is the product of the probability of A and the probability of B after A. Okay, so that becomes 1 over 2 multiplied by 4 divided by 51. So 1 times 4 is 4. 2 times 51 is 102. Okay, and we know 2 will go into 50 into 4 2 times, and 2 goes into 102 51 times. So 2 divided by 51 is the probability for A and B occurring. Okay, so that is it, and thank you. See you in the next video.